Today we're talking about adding and subtracting rational expressions. We talked about simplifying complex fractions yesterday. What you need to realize today, like if you look down at example 3, is there's no equal sign. So we can't get rid of our fractions. The only way to add fractions is that they need to have what?
Same denominators.
Same denominators. Okay. LCM stands for least common multiple, which is basically the same thing as least common denominator. It's just when they say LCMs, they're just talking about that term and not making it a fraction, because denominators are fractions, right? Bottoms are fractions. So when you're finding your least common multiples, sometimes you may need to factor. If they share the term, you only use one of that number. If there's anything that is not common or not the same, you also need one of those. Because remember how yesterday you're always going to have at least as big as the biggest number. So you're going to need everything that the denominators have. And if they share something, you only have to count it once. Okay? And then you'll multiply everything together. So part of your homework, like the first part on page 586, is just asking you to find the LCM. So that's what we're going to do on the first examples. We're just going to figure out if these were like the denominators, what would the common denominator be? Okay? So for x, if you were to kind of break that apart, that would actually be 2 times 2 times x. Is everybody okay with that?
We have to write that down?
I would. And then this is, 2 times x minus 1. So do they have anything that they share in common?
2.
They each have a 2. Now, if you notice, they each have this 2 in common. So I'm going to write that they have 2 in common. They don't have a second 2 in common, but because there's a second 2 on one of them, I have to write that 2 again. So this second 2 that I wrote was from here. This 2 was the 2 that they shared. Okay? So we wrote the one that they share, and then we have to have one more because this one has one more. Okay? Then, is x the same as x minus 1? No. So we have to write the x, and then we also need to write the x minus 1.
So wouldn't we get the same answer when we get...
Okay, so we multiply all of that together, and we end up getting,
4x
so that would be my least common multiple, or my least common denominator. Okay. So we're trying to figure out what would be the common denominator. If these were fractions, those two numbers were fractions, those were your denominators, we're trying to figure out what would be my common denominator. Okay? You need at least as big as your biggest number, which in this case, if you look at 4 and 2, 4 is your biggest number. So I need 4, and since 2 goes into 4 evenly, 4 is good. Since this has a plain x, we need a plain x. Since this has an x minus 1, we need an x minus 1. So that would end up being my common denominator. Does that make more sense? And we're going to keep practicing, okay? So it's our first one. So on this one, same thing. We're trying to find the least common multiple or least common denominator.
2x plus 4 x minus 1?
So we're first going, to factor. This is difference of squares because 9 is 3 squared, x squared, and 16 is 4 squared. So we can factor that, and it is
3x plus 4, 3x minus 4.
good. 3x plus 4 and 3x minus 4. So we'll also need to factor,
Bottoms up.
yes, and we're going to use our bottoms up over under method. So we go over by 3,
And get 24
x squared minus 2x, and we go 3 times negative 8, which makes
negative 24.
negative 24. So now again, remember that you can use your diamond method at this point if you want to. We're looking to see what adds to be negative 2, what multiplies to be negative 24. Good. X minus 6 and x plus 4 is correct. Those add to be negative 2, multiply to be negative 24. But since I went over, I still need to go
Under. By
under. Very good. And we're going under by 3.
So that would be x minus 2,
Good. So that reduces to be x minus 2.
3x plus 4.
And bring our bottoms up, and we have 3x plus 4. Okay. So looking at these two terms, do they have anything that is the same?
3x plus 4.
Very good. So 3x plus 4, I only have to write that once because they both have that in common. Okay? So we have 3x plus 4. Do they have 3x minus 4 in common?
No.
No, but we still have to write that. Anything that they don't have in common, you also have to write. And then I also need to write the
That's
Wait, so then
x minus 2.
Where-
x minus 2.
Then 3. That's pretty easy.
So again, we're just basically pretending like these were denominators and we're trying to figure out what would be my common denominator. That's how the first part of your problems are when you're finding the least common multiple. So whatever they have in common, you only have to write that one time. Anything they don't have in common, you also write that. Okay. So moving on to example 3 when we're actually moving into the problems. So we have to find a common denominator. I don't have to factor on either one of these. Do they have anything in common?
12.
Do they have anything in common?
X plus 4.
No. Okay? Because x, whenever they're connected by a plus or a minus, they're like stuck together like glue. Okay? And so x plus 4 and x plus 6 are totally different. So that means we're going to put both of them together to be my common denominator. Okay? So what I normally do is I'm going to write my two fractions. I have my minus there in the middle. And I'm going to rewrite my denominators for what I want them to be. X plus 4 and x plus 6. Okay, because that will need to be my common denominator. Are we all okay with that?
What about your top?
So now we go back and we look at our first fraction. So right now I have an x plus 4, but I needed to multiply by what?
X plus 6.
So whatever you did to the bottom, we also do to the top. I'm multiplying the top and bottom by x plus 6. But there's already a 3 there. So what do I do?
That's a mess.
Distribute. We're going to go 3 times x is,
3x plus 18.
and 3 times 6 makes 18. On the second fraction, I have an x plus 6, and so that means I'm multiplying by what to the top and the bottom? X plus 4.
So it just equals x plus 4.
Good. And we distribute the 1, and it doesn't change it, and so I have x plus 4.
4x.
Now, before you do anything, notice that this is a minus sign. So what you need to do is you need to distribute that minus sign to everything on top. So that is going to end up making this x a
Negative.
and the 4 also a negative. And then once you do that, you can change that to a positive. So anytime you have a minus there, you need to distribute it to everything on top. Now you can combine your like terms. So 3x minus x makes 2x. And 18 minus 4 is,
Also 14.
and this is over x plus 4, x plus 6. No. So if you can factor the top, you want to factor it. Can I factor or do anything with the top?
Yeah.
Good, we can take out a 2. So we take out a 2, which means we'll end up with,
X plus 7.
and then this is still over x plus 4 and x plus 6. And is there anything that I can reduce? No. So this ends up being my answer. But you always need a factor in case you could end up canceling out something with the top and something at the bottom. Yes?
Why wouldn't the negative distribute?
If you distribute it to both the top and the bottom, that's really distributing a positive because 2 negatives make a positive. And you want to keep the bottom how it is because you want the like denominators. So, yeah, you could distribute it to either the top or the bottom, and we choose the top because we want to keep our denominators the same. Okay?
Okay, and another question. Why did you do x plus 6 and not x plus 4? When you multiplied it, on the beginning, you multiply x plus 4 by x plus 6. Oh, you did it to both sides. I didn't write those.
Yeah, so we want our common denominator, so whatever was missing is what I multiply the top and bottom by.
Oh, okay.
We're good?
Yeah, I didn't write that.
No problem. All right. Any other questions? Let's move on. Okay, so on example 4, what do you think I'm going to need to do first? Good, factor. Okay, so we're looking for something that multiplies to be 5. Or sorry, multiplies to be negative 14 and adds to be 5. What numbers work?
7 and 8.
Good. X plus 7 and x minus 2. So those 7 and negative 2 add to be a positive 5 and multiply to be negative 14. So what do you think my common denominator will be on this problem? Very good. X plus 7, x plus 2. So I'm going to rewrite each of these fractions.
X minus 2.
Thank you. That was supposed to be a minus 2. X plus 7, x minus 2. Okay, and don't forget we had that minus there. On the first fraction, is there anything I need to multiply by in order to make it the common denominator? No. So we just rewrite what was already there, which is x squared minus 5. On the second fraction, what am I missing? X minus 2. So that means I'm multiplying the top and the bottom by x minus 2. Now, over here we have x plus 3. So what are we going to have to do in order to multiply that? You need to do your box or FOIL method. Okay, so if I do the box method, we have x and a positive 3, x and a negative 2. We get x squared, 3x, negative 2x, and a negative 6. So that ends up becoming x squared plus x minus 6. Negative 3 and positive 2 makes a positive 1. Or, I said that backwards. Positive 3, negative 2. All right. What do I need to do now? I heard somebody say it. Good. Distribute that negative to the top of that second fraction. So we get a negative, and a positive. Once you distribute that negative, you change this now to a plus, and we can now combine our like terms. So x squared and negative x squared, those cancel out. Then next, you would go with your plain x term, and there's only one of those, so I have negative x. And then negative 5 and a positive 6 make positive 1. And then this is over x plus 7, x minus 2. Can I factor or do anything with the top that would end up making it so it could reduce with something at the bottom? No. So that's your answer. Questions on this one? All right.
Next one you found.
Good.
Why did we use x plus 7 and x minus 2?
Because this one has x minus 2 and x plus 7, and so you always have to use at least as big as whatever they have. And since this had an x plus 7, that's where like these both shared the same.
Okay.
And so we only had to write it once. Okay. Any other questions? All right, example 5. So the first thing you're going to do here is factor this, and x squared minus 25 factors to be what?
X plus 5, X minus 5.
Good. X plus 5 and x minus 5. So we need to make, there are 3 fractions this time. Okay, so I'm going to write 3 fractions. And what do you think that my common denominator is going to end up being?
And plus 5.
So they share the x minus 5, right? So we're going to need an x minus 5. And then we still need a x plus 5. Very good. And we need an x plus 3. So this time there are 3 on each of the bottom of the fractions. Yes?
Can we write x plus or minus 5?
No. You need to write them separate like that. Okay, so then we have minus, and I'm going to write each of these 3 times. So we have x minus 5, x plus 5, x plus 3. And then our last fraction. Okay. So on my first fraction, what am I missing?
An x plus 3.
Good. We are missing the x plus 3. So whatever I multiply the bottom, I have to multiply to the top. So x plus 3 and x plus 3, you'll need to use FOIL or your box method. I'm going to do this one in my head. We get x squared. On the adding number, positive 3 and positive 3 adds to be positive 6x. And then when I multiply positive 3 times positive 3, it makes a positive 9.
Wait, why can't you just write x plus or minus 5?
Because that would not be saying that it's being factored. It would just say x plus or minus 5. You need to have it written out for these. You could end up writing it as x squared minus 25 at some point.
Yeah.
But for right now, you want to leave the denominators like this. Was there an issue with me multiplying here? The x plus 3 and x plus 3? Okay. Now, the second fraction. What am I needing to multiply the top and the bottom by? Very good. X plus 5 and x plus 3. And we have our x minus 1. So how do you end up multiplying?
You do 2 and you do.
Good. You do 2 together, get the answer, and then you'll have to multiply it by 1 more. Okay. So in my head, it's easy for me to do these 2 together because they're both positives. So if I'm multiplying x plus 5 and x plus 3 together, I'm going to get x squared. Positive 5 and positive 3 add to be positive 8x. And then positive 5 times positive 3 makes a positive 15. So I took care of those 2 parentheses. Sorry. So now I have to multiply x minus 1 and x squared plus 8x plus 15. So I would use a box for this or your FOIL method. So that box, if you use a box, it's going to be 3 by 2. And we have x and negative 1 and x squared, 8x, and 15. When I multiply through by that, we get x to the third, 8x squared, 15x, negative x squared, negative 8x, and negative 15. We have our like terms in the diagonals. So when I write all that out, it's going to start with x to the third. 8x squared and negative x squared makes a positive 7x squared. 15x and negative 8x makes a positive 7x. And then I have minus 15. Okay, on the last fraction, what am I missing? Good, I'm missing x plus 5 and x minus 5. Well, how does x plus 5 and x minus 5, what does that multiply out to be? It's a difference of squares, right? It's x squared minus 25. Are we all okay with that? And then I just have this 3 here that I have to multiply through. So on the top over here, I'm going to end up with what? Good. 3x squared minus 75 is correct. Okay, now what do we need to do? Very good. Check for any minus signs. So we're going to take that negative and distribute it to the top right here. So we get a negative x cubed, a negative 7x squared, negative 7x and a positive 15, and that minus changes to a plus. We always write our answers in descending order. So what would be the highest exponent I would write? Good. Negative x cubed. So I'm going to cross this one out so that I know it's done. So I'm crossing out the negative x cubed. Okay, what's next? X squared. So I have a 1x squared, a negative 7x squared, and a 3x squared.
So let's do the adding first. Let's go 4x squared.
Okay, so 1 plus 3 is 4x squared.
And then the negative 7x squared.
Mhm.
And then let's just go negative 3x squared.
Perfect. Okay, and then I'm going to cancel all those out again so that
And then
I know they're done and I don't have to think about it.
And then we have to go to the x's, so we have combine 6x and 7x.
Okay,
7x.
6x and negative 7x makes
Negative x.
negative x.
Cross those out. Let's add again.
Okay,
And do 9 and 15, which equals 24. Then subtract that from 75 and we get 51.
positive or negative?
Negative.
Good.
Is this how our homework is?
Yeah, I'm on a roll.
I kind of did the harder problems.
And could you
For our
do
homework?
grouping?
Are you sure?
It's 51.
Negative 51.
And can you do the grouping?
You can do the grouping, but it doesn't end up making a like,
Oh, yeah, that's true.
so you can't end up factoring it. And what, because if you group the, well, let me just finish. This denominator is x minus 5, x plus 5, x plus 3. If you were to try to group, okay, if you look here, I could take out a negative x squared, but then I'd end up with x plus 3. There's no way to end up with an x plus 3 here. So it's not factorable. So that makes this your answer. The negative x cubed minus 3x squared minus x minus 51 all over x minus 5, x plus 5, x plus 3.
Yeah, have you seen the previous one?
Any other questions on this?